Okay, let's give you guys an example. So in the previous video, we've seen this. The arc length is given by this. And remember, well, the radius is a function of the angle. So we can put the r into f of theta. So that can become this. And then instead of f prime of theta, we can write it as dr by d theta. So we can put this into here. So this thing here will become this. So the arc length can be written as this, or it can be written as this. You can switch these two around, and sometimes it can be written as this. So in this video, we are going to make use of this. The arc length is given by this. Okay, so let's put it to use. So let's try and find out the arc length of this. So remember, the angle starts at 0. So theta is increasing from 0 all the way to 2 pi. So we need to integrate it from 0 all the way to 2 pi. So the formula of the arc length, is given by this. So looking at this, if you want to know the arc length, you would need to square the r here. So we need to square this. So basically, we need to put this into the r here. And then looking at this, if you want to work out the arc length, you would need to know dr by d theta. So you would need to differentiate this. So differentiating it will give you this: dr by d theta equals minus 2 sine theta. So now we can put this into here. So when you come to square it, the minus goes away. So anyway, put dr by d theta into here, square it, and then put this into here, square it. Well, put this into here, put this into here, it will then become this. It will then become this. Okay, so you've got a minus here, but then when you come to square it, the minus disappears. So from here, so remember, we're integrating from 0 to 2 pi. So let's try and multiply this out. So that will then give us this. Square this, it will then give you this. And then now tidy this up. If you look at this, and if you look at this, you can factor out the 4, and then this course here becomes, well, it will then be this, and then this is 1. So it just becomes 4 here. So it will then become this. And now factor out the 8. Factor out the 8. That will then give you this thing times this thing here. And then remember, root a b, that's the same as root a times root b. So that will then give you this. And then this is a constant. Take it out. That will then give you this. So now it's a matter of us integrating this from 0 all the way to 2 pi. So to integrate this, use a double angle here. Bear in mind that this angle here is always twice the angle here. Okay, so if you look at this here, if you times both sides by 2, that will then give you this, and then this is very similar to this. Just bear in mind that this angle here is always twice the angle here. Well, making use of this thing here will then become this. Okay, so remember this angle here is always this angle here is always 2 times bigger than this angle here. That's why you got this as being half of the angle. Well, think about it. This will then make use of this thing here will then become this. Okay, and then break this up. So you got a square. Well, break this up. That will then give you this, and then this is a constant. Take it out. Then that will then become, because this thing here will then become 4, because square root of 4 is 2. This thing here will be another 2. So that will then give you a 4 here. And then when you square root a square, it becomes this thing here. So now it's just a matter of us integrating this. So integrating that will then give you this from 0 to 2 pi. So if you put 2 pi into here, this 2 pi divided by 2, that will be pi. So cos of pi is negative 1. Negative 1 times negative 2, that will give you a positive 2. And then put 0 into here. 0 divided by 2 is 0. Cos of 0 is blah blah blah. This thing here will then become this. So now your final answer will be 4 times 4, which is 16. So this here is your final answer. This here is the length. Hang on. That 16 there is, hang on. That 16 there is the length from here all the way around here. Okay, so your final answer is 16. Okay.